Yes, sir, you're audible, sir.
Thank you, sir.
Yes,
Great.
you may start the
So we'll
session.
start today's. Thank you.
Yes, sir. Yes, you. Thank you, sir.
So hi, hello everyone. We'll start today's session with a question related to implicit differentiation. So as you all remember, how do we do implicit differentiation? That whenever we have the term y, wherever we have the term y, we treat it as a function of x, as any random function of x given to us. Okay. So you have been given a function. And it is asking you, fine. So this curve has been given to you and it is asking you the slope of the tangent. The slope of the tangent is also equal to dy by dx, fine. So it is asking you what is the value of dy by dx at 1, comma 3. So 1, comma 3 would mean that x is equal to 1 and y is equal to 3. So obviously this point x is equal to 1 and y is equal to 3 will obviously be a point on this curve. Fine. Let me see who all are there. Ashrita, Vignesh, Bhavna and Gayatri. Okay, fine. So as we were discussing yesterday, implicit functions differentiation. So tell me, what would be the first step that we do over here? Anyone? First step that we apply over here. Gayatri, Bhavna, Vignesh. I want to find dy by dx. What should I do?
Differentiate with respect to x.
Great, great, great. I want to differentiate with respect to x. So, okay, so do you want to do the left side first or the right side first?
Left side.
Both are equally tough. Okay, fine. So let us do the left side first. So you need to differentiate this thing, y minus x raised to 5 whole square, y minus x raised to 5 whole square. So can you tell me which function has been inserted inside which function? Really easy.
Y minus x raised to 5 inserted in the x square, sir.
Great. Is inserted inside x square. So you approach from outermost side. The first function that you get is x square. You differentiate it, you get 2x. So on the left hand side, the first term that you write is, what will be the first term?
2 into y minus
Y
x.
minus x raised to 5.
Great. Into. I complete this level. What will be the derivative of this thing? Y minus x raised to 5. What will it be?
dy by dx minus 5x raised to 4.
Great. Great.
5x
So this is my left hand side. My left hand side has been completed. Do you all agree?
Yes, sir.
Great, great, great. Now let us do the right hand side. So in the right hand side, I got, so this was my left hand side. Now I'll do a right hand side. So it is x into 1 plus x square whole square. So it is a product of two functions. How do you differentiate product of two functions? You take one derivative of one at a time, right?
Yes, sir.
Yes, sir.
Derivative of one at a time. So first you differentiate the first function. So you'll just get 1 into your second function, right?
Yes.
Derivative of x is 1 plus. Now you take x as it is and differentiate the second function, right? So now basically you need to calculate what is the derivative of 1 plus x square whole square. 1 plus x square whole square. Which function is inside which function?
1 plus x square
Inserted into x
inserted in
square.
x square. Inserted inside x square.
Great. You approach from outermost side, you meet x square, you differentiate it, you get 2x. What will be the first term that you write over here?
2
2 into
into
1 plus x raised to x square.
Great. What about the next term?
2x, sir. 2x, sir.
Great, 2x. That's it. That's it. Right? No more terms?
No, sir.
Okay, great. So the right hand side you get 1 plus x square whole square plus. So it will be 4x square into 1 plus x square, right? So this is what you'll get on the right hand side. And on the left hand side, you'll get this thing. So obviously my left hand side derivative and my right hand side should be equal. So I'll just equate both of these things. It is both of these are equal, and it's been told to me that the point is already given to me. The point is 1 comma 3. So x is 1 and y is 3. So what can I do next? What will be my next step? I'll just substitute the values, right? Just
Sir.
substitute the value. So you'll get 2 into y minus. So 3 minus 1 raised to 5. So 1 into dy by dx minus 5x raised to 4. What is the value of 5x raised to 4? 5, right?
5,
X is 1.
Yeah.
Right. So 1 plus 1. So it will be 4. 1 plus 1
4.
whole square. Right? Plus 4 into 1 into 2. Right?
8, sir.
Right? Yeah. 8. 8 plus 4 is 12. So this thing is 4 over here. So dy by dx minus 5 is equal to 12 divided by 4. Right? Just calculations. So you'll get 3. So value of dy by dx is how much?
Minus 2.
8.
8, sir.
Yeah, sir. Yeah,
It is 8, right?
yeah.
Sir.
Yeah,
Eight,
sir.
sir.
It is 8. Everyone.
Yes, sir.
Yes,
Okay, got
sir.
it. This was a PYQ of JEE Advanced only. I don't know. It was which year? I guess 13 or 14. Don't remember exactly. Okay. But it was really, really easy question. Like all you needed to do was just apply a basic chain rule. Fine. Okay, great. Then let us just do one more question related to this chain rule stuff. So you have been given a function f of x whose value is x cube plus e raised to x by 2. Okay. E raised to x divided by 2. And you have been told that g of x is a function that is inverse of f of x. Every one of you know what is the meaning of the word inverse of a function? We have discussed inverse of a function, everyone. Remember?
Yes, sir.
Okay, great. So every one of you remember, right? We have discussed inverse of a function. So inverse of a function basically means, so okay, we'll do that now. And it is asking you the value of g dash 1. Fine. It is asking you what is the value of g dash 1. Double derivative, single derivative of inverse. How will you differentiate the inverse? Do we have any property related to the inverse? If you remember exactly. First of all, what is meant by the word inverse? Inverse of a function. What does it give you? Anyone who remembers inverse of a function? No one. Okay, fine. So I'll just revise you a little bit. So when we were learning about functions, so for example, I told you that treat it like a mixer. Fine. This is your function f of x. So over here, what you are doing is you are sending an input x. It is doing some properties. It is doing some operation on it, and it is giving you some value output y or some value, okay, as output. What will f inverse x do?
Y will be
F-
the
Yes, correct. The
input and
value of
X.
y, the value of y will be the input.
And
Okay.
output is X.
Yeah,
Yes.
correct. Value of x. Right? So basically it will tell you that particular value that can be inserted into that function in order to get the same value of y that you have got. So for example, over here you have got f of x and you have got, you know that g of x is f inverse of x. So can you tell me what is g of 1? G of 1. Like what value will you put in x over here? Okay,
One,
what
sir.
value can you put?
One.
Are you sure it is 1? No. If you put, okay, just a minute. I'm basically asking you what is the value of f inverse of 1. So f inverse of 1 basically means I have got this function f of x. What value of x should I be putting in it so that I get 1 as the output? Okay. What value of x should I be putting in this function so that I get my final value as 1? Can you tell me, anyone?
The
What
zero.
value should I be putting?
Zero,
Yeah,
sir.
0.
Zero, sir.
Yeah, right, because f of 0 is 1, right?
Yes, sir.
Everyone, f of 0 is 1. So f inverse of 1 is 0. This is how it works.
Oh.
Do we have any property related to inverse that can help us in chain rule? Anyone remember any property related to inverse? Okay, fine. So let us just revise it then. So f inverse of f of x. Can anyone tell me what will be the inverse of f of x? Like I am making a function f of x. I am inputting that inside the inverse. What will it give me? Or you can see it the other way around also. F of g of x or f of f inverse x. Anyone? So basically f inverse of f of x is x and f of f inverse x is also x. We have discussed this in relations and functions, right? So basically what is happening is if you are inputting the same value of f of x, okay. So what is happening is this f inverse will tell you for what value of x you will get this value. So obviously you are inputting the value x, so you'll get x over here, right?
Yes,
Basic
sir.
logic. So yeah, like you don't need to think much about it. So fine. So this we have, and it is already told to me that g of x has been named as f inverse x. So I'll just take it like this. Instead of f inverse, I'll just write this g. Right? Is this right, everyone?
Yes,
Sir.
sir.
Yeah. Okay, great. So obviously it is asking me the derivative of this thing, g dash. So I should differentiate this thing. X on both sides. Okay. Can you tell me what will be the right hand side if I differentiate it with respect to x?
One.
Derivative of right hand side 1, right? On the left hand side, I am basically asking you the derivative of g of f of x. Can we do this? G of f of x. So basically what is happening is inside g of x, f of x has been inserted, right? Agree, everyone?
Yes, sir.
Yes,
Yeah,
sir.
right. So if I approach from the outermost side, I meet the function g of x first. I differentiate it. So what will be the first term that I write over here? Anyone?
Derivation of g of f of x.
G
Okay,
dash of f
Yes,
of
sir.
x, sir.
great. It will be g dash of f of x. Great. Multiplied by, I complete my first level, I moved inside. The next term,
F dash.
F dash x.
great, great, f dash x. So basically I can tell you that g dash of f of x is basically 1 by f dash x, right? Right? I can just take this down over here. So can you just calculate the value of f dash x for me? Because I need f dash x over here. Anyone who can tell me what is the value of f dash x? So f of x has been given to me x cube plus e raised to x by 2. Can you tell me what will be the value of f dash x? What is the derivative of x cube?
3x
Three
square,
X
sir.
square.
Okay, great. This one was really easy. Now you have got e raised to x by 2. Can you differentiate this thing? E raised to x by 2. Which function is inside which function? Again,
E raised to x.
e raised to x.
X by 2 is inserted in the e raised to x, sir.
Great, correct. So you approach from outermost side, you meet e raised to x. So what is the derivative of e raised to x?
E
E raised to
raised
x.
to
X only, sir.
So what will be the first term that comes over here?
E raised to
E raised to
x.
x.
E raised to x will be the
X by 2, sir.
what? Yeah, e raised to x by 2
But
multiplied by.
yes, yes,
What will be the next term that comes over here? Next term.
1 by 2, sir. 1 by 2,
Great.
sir.
Yes, sir.
Great. Because you need to differentiate this thing, right? So you'll get 1 by 2. Great. 1 by 2. So you have got this value. So just substitute it over here. Right? This is correct now?
yes, sir.
Yes, sir.
Great. But what is it? What is the question asking me? It is asking me the value of g dash of 1. G dash of 1. I know the value of g dash of f of x. So what can I do is place such a value of x. Right? If I take such a value of x where f of x is 1, so my left hand side will become g dash of 1, right? I take such a value of x where my value of f of x is 1. So can you tell me for what value of x is my value of f of x 1?
0.
What value of x should I be putting? Yeah, great. 0.
0, sir.
So basically I am taking my x to be equal to 0. Really simple. I will take my, if I take my value of x is equal to 0, so I'll get 0 plus e raised to 0. So that is 1. So basically I'll
Yes.
get my left hand side as g dash of f of 0. That is g dash of 1. So I just substitute x as 0. So I'll get 1 by 0 plus half e raised to 0. So it is 1. So I'll get my final answer as 2. Right, everyone? Everyone agree with this?
Yes, sir.
Yes, sir.
Great. Yeah, great. Correct. Okay. Fine. So just one small concept related to chain rule. That, for example, you have been given a function, you have been given two functions, y is equal to f of x, and other function is y equal to g of x. Okay. So basically, two functions, f of x and g of x, have been given to you. Both are continuous and differentiable. So currently, no need to check continuity and differentiability. And you have been asked what would be the value of like derivative of one function with respect to another function. So till now, you have been differentiating functions. Okay, like this. That you have got a function, you are differentiating it with respect to x. But what if you need to differentiate one function with respect to another function? So for example, I ask you the derivative of f of x with respect to another function g of x. Can we apply chain rule in the same way? Can we apply chain rule? So what you can do is, if I divide both my numerator and denominator, right? So what will be my numerator? Anyone? What will be my numerator?
Sir,
F dash x.
What is
dash
what is
x.
it? Yeah,
F
great.
dash
It is f dash x.
Yes, sir.
What will be my denominator?
G
G
dash.
dash x.
G dash x.
Yeah, yeah. So this is it, right? So basically, now you can take the derivative of one function, not with respect to a variable, but with respect to other function also. That is also possible. So let us just directly move on to a question related to this. So you have been given that the derivative of f of tan x, f of x is any function, f of tan x with respect to g of secant x at x is equal to pi by 4. Okay. And it is, okay, so it is asking you what is the derivative of f of tan x with respect to g of secant x at x is equal to pi by 4. And it is being given to you that f dash of 1 is 2. Okay. And g dash of square root 2 is 4. Fine. So it is asking you the derivative of f of tan x with respect to g of secant x. So basically, just treat this as one function. So you can just name it anything you wish to. So I'll just name it as some function h of x. H of x is f of tan x. And what should I name it? I can name it as any function. Let me just name it c of x. Fine. So it is asking me what is the derivative of h of x with respect to c of x, right? So as you can see, I need to differentiate h of x with respect to a function, not with respect to a variable. So what can I do? I can apply the same trick, or I can do the same thing that I have been doing just above, just now, what we have done. So if I divide the numerator and denominator both by d of x, I'll get f dash x divided by g dash x. So can you tell me what will be my this thing? I'll get h dash x divided by c dash x. Can you help me in calculating my h dash x? So my h dash x basically means what? H dash x means d by dx of f of tan x. Can you tell me f of tan x? F of tan x, which function has been inserted inside which function?
Tan x is inserted
Anyone?
in the f of x.
Great. Great. So I approach from outermost side. The first function that I get is f of x. I differentiate it. I get f dash x. So what will be the first term that I write over here?
F
F
dash tan
Dash
x.
tan x, sir.
Great. F dash of tan x. Great. What about the next term? I complete this level, move inside. I met tan x. What will be the next term that I write over here?
Secant square x, sir.
secant square x.
Great. So this is my overall derivative of f of tan x. So same way about my c dash x. I need to calculate my c dash x. So c dash x means what? It means d by dx of g of secant x, right? So again, I got g of secant x. So which function is inside which function? G of secant x.
Secant x
F
is
x
inserted
is
in g of x.
inserted in
G of x, sir.
Great. I approach from outermost side. I meet my first function, g of x. I differentiate it. I get g dash x, right? I get g dash x.
Yes, sir.
Okay, great. So I get g dash x. So what should I do next?
G dash of secant x we have to write.
Great.
difference.
You get g dash of secant x, right? G dash of secant x multiplied by. I complete this. I moved inside. What will be the next term?
Tan
Secant
square.
into tan x, sir.
No, it will be secant x into tan x, right?
Yes, sir.
The derivative of, yeah. Right.
Secant.
So basically my, this thing, d of h of x divided by d of c of x. So derivative of h of x with respect to c of x is basically h dash x divided by c dash x. So I'll just write it directly. H dash x divided by c dash x. So I'll just write this thing directly. So I've got f dash of tan x into secant squared x whole divided by g dash x, g dash of secant x into this thing.
Instead.
So this is what I get. So I can just cancel it out. And it's been told to me that the value of x is pi by 4. The value of x is pi by 4. So if I substitute x is equal to pi by 4 directly inside, so I can just put it. So can you tell me what is f dash, what is tan of pi by 4? Tan of pi by 4. Anyone?
One, sir.
Great, it is 1,
Yes, sir.
right? Into secant. What is secant of pi by 4? Sec
Root 2,
of pi
sir.
by 4.
Root 2.
Root 2. Great. Great. Whole divide by. What is tan of pi by 4? 1. Again, right?
One.
And secant is again.
Root 2.
And the values are already given to me. Okay. F dash 1 is given to me as 2. And this value is given to me as 4. So f dash 1 is given to me as 2. So it is 2 into root 2 divided by 4. Right? Because this value is given to me as 4. So my final answer that I get is 1 by root 2.
1 by root 2.
Right?
Yes, sir.
Everyone?
Yes,
Got
sir.
it?
Yes, sir.
Great. 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 So, okay. So till now we have done implicit functions and we have completed chain rule up to a very good level. So I just want to give you one small homework related to this chain rule stuff. Okay. So you have got a function f of x equal to x cube plus 3x plus 4. Okay. And g of x obviously is the inverse of f of x. So again, if you have got the inverse, again, you know what to do. Okay. And it is asking you what is the derivative of. So it is asking you d by dx of g of x of g of x divided by g of x. Okay. It is asking you this thing at x is equal to 4. Fine. At x is equal to 4. Okay. This, okay. So this one is it. So today we'll be discussing about logarithmic differentiation. So what is meant by logarithmic differentiation is, till now we have been discussing some special cases related to functions. So for example, till now we have discussed what will happen if two functions are multiplied, two functions are added, they are subtracted. What will happen if two functions are multiplied with each other or divided by each other, or if one function has been inserted inside another function. Till now we have discussed such a case. What will happen if one function is raised to the power of another function? How will you differentiate this thing? How will we differentiate such a thing where one function has been raised to the power of another function? You all can easily recognize that it is not a part of what we have done till now, right? One function being inserted inside another function we have done, but one function being raised to the power of another function we have not discussed till now. So this falls under the topic of logarithmic differentiation. So what we do in this case is really, really simple. All you need to be equipped with is you just need to know what is the derivative of log x. Everyone remembers what is the derivative of ln x? Derivative of ln x, everyone?
Sir, is it 1 by x?
Yes, it is 1 by x. We had derived it, right? Yeah, we had derived it using chain rule. And the next
Yes.
thing you should be knowing is chain rule. And chain rule we have discussed just now, so I hope all of you remember it. So great. Derivative of ln x is x, ln x is 1 by x, and obviously we will know chain rule. So for example, I'll just like without starting, I'll just give you one very small example. So for example, you have got this really simple case. So let us just take any functions, f of x raised to any function g of x. Okay. I'm asking you to differentiate this stuff, f of x raised to g of x. So what we can do is we can take the logarithm on both sides, the natural log on both sides. So ln of y. So if I take the natural log of f of x raised to g of x, so this thing will become, so I hope all of you remember, we have a property of logarithm that if you have a power in logarithm, it comes out to the front. Everyone remembers this?
Yes, sir.
Okay,
Yeah,
great.
sir.
Great. So this thing becomes g of x into ln of f of x, right? Everyone, is this correct?
Yes, sir.
Yes,
Yes, sir.
sir.
Okay.
Yes,
Now
sir.
I ask you to differentiate with respect to x on both sides. Okay. On both sides, I want you to differentiate with respect to x. So let us do the right hand side first. Or okay, fine. Let us do the left hand side first. So you have been given d by dx of ln of y. ln of y. You have got ln of y. Which function is inside which function? We have got natural log of y. So you can directly see that ln of x inside that y has been inserted. Is this
Yes,
correct, everyone?
yes, sir.
Right? So you start from the outermost side. The first function that you get is ln of x. You differentiate it, you get 1 by x. So what will be the first term that I write over here?
1 by y.
The first term will be 1 by x. Yeah, great. It will
1
be
by
1 by
y,
y.
sir.
Yeah, great. 1 by y. I completed this level. I moved inside. I met y. What is the derivative of y?
dy by
1.
dx.
What is it? dy by dx, right? Correct. It is dy by dx, right? That is what I was trying to find. I was anyways trying to find dy by dx only, and I have already got a term of dy by dx. Fine. On the right hand side, I have got the derivative of g of x into ln of f of x. This one is a little bit tougher because first you need to apply product rule, after that chain rule. So you have got the product of two functions. Over here, you have got the first function as g of x and your second function ln of f of x. What will you do? How will you apply product rule? So you will differentiate one function at a time. So I
Yes.
differentiate the first function and keep the second function as it is, right? After that, I keep the first function as it is and I differentiate the second function.
Yes, sir.
So I have got ln of f of x, natural log of f of x. Can you tell me which function is inside which function?
F of x inserted in
Natural
the
log of,
ln x.
yeah, great. So I approach from outermost side, I need ln x. I differentiate ln x, I get 1 by x. Fine. So can you tell me what will be the first term that I write over here?
1 by f
1
of
by
x.
f of x into f dash x.
Great. Right? Is this correct, everyone?
Yes, sir.
So let us
Yes,
just
sir.
equate both my left hand sides and my right hand sides. So I'll just do that in a minute. So I'm just equating the both my left hand sides and my right hand sides. Right? So you can just see over here that I have got my dy by dx, and I have got all the other terms related to g dash x, ln of f of x, and 1 by y. Fine. So I have my value of dy by dx. Do you all agree? I have my value of dy by dx. Everyone, what do you feel?
Yes, sir.
Yeah. So I have calculated my dy by dx. I just need to shift this y to the right hand side.
Yes,
So
sir.
I have my dy by dx already. Fine. So this was the overall procedure of how we go about calculating uh, when one function has been raised to another function. So let us give it a try. Let us try a few questions on it. So you have been given y as x raised to x. Fine. One of the easiest cases. So what can I do? I'll take logarithm on both sides. So I'll get ln of y is equal to x into ln of x, right? So ln of x, I've got this. So can you tell me what will be the derivative of the left hand side with respect to x? Anyone?
1 by y.
Let's do it fast.
1 by 1.
1 by 1 by y,
1 by
that's
y
it.
into dy by dx.
Great. Is equal to. Now I want you to differentiate the right hand side with respect to x. So you have got product of two functions, right? Product of two functions. So you keep the first function intact, differentiate the second function, plus then you do the other way around.
1 into log x.
1
ln
into s.
Yeah,
ln
1
x.
into ln x. So what will be the right hand side that I get? I'll get 1 plus ln x, right?
Yes, sir.
Great.
Yes,
So
sir.
I get my value of dy by dx as, so I can just put this y on this side. So I'll get y into 1 plus ln x, right?
Yes, sir.
So I'll get,
Yes, sir.
what will I get? I'll get x raised to x into 1 plus ln x, right? So this is my derivative of x raised to x. Fine, everyone?
Yes, sir.
Okay. Fine. So you have got x raised to sine x. Let us see how we can do it. So I take logarithm on both sides. What will be my right hand side if I take logarithm? Natural log.
Sin
Sin
x.
x log x.
into ln x.
Great. Sin x into ln x. Till now, it is really easy because we are just taking ln of x. If we take ln of something else, so it will even be tougher. So obviously, if I differentiate it with respect to x, so on the left hand side, it is really easy. I'll just get the same
1
thing
by y
again and
into
again, right? I'll get 1 by y into dy by dx every time. So you can just memorize it, but don't actually. Okay. What about my right hand side? So I've got product of two functions. First function is sin x, second function is ln x. So I take the first function, keep the first function intact, differentiate the second function, plus
1 by
the other way around,
Cos
cos
x
x
ln of x.
into
Cos x.
right?
Yes,
Yes.
sir.
Okay. So what will be my value of dy by dx?
y into y
Into
into
y 1 by
sin x
Y into this whole thing.
Y
So
into
I'll
1
just write
plus
it
cos
directly.
x ln x.
to ln
Great.
of x.
So I'll just write it like this only.
So can't we write sin x by x is 1?
No, no, no. That is when limit x is tending to 0.
Okay, sir.
Sin x by x is 1 only when limit x is tending to. Don't confuse the two things. They are completely different. Fine. Okay.
yes sir.
Great. So let us just see. All you should be familiar is that how to apply chain rule. Okay. If you are comfortable with chain rule, everything will go fine in this case. So obviously, I take logarithm. I'll take logarithm. I'll get ln x into ln of sin x. Right. Now the difficult part starts. We have got natural log of sin x. So I get left hand side as 1 by y into dy by dx. What about the right hand side? Can you differentiate this thing for me? Can you help me differentiate my right hand side? Anyone?
Yes, sir.
It is product of two functions, right?
Yes, sir.
So I want, okay, so let's first differentiate the first function. Okay. So it,
1 by
derivative of first function is 1 by x.
1 by x.
So
1 by
1 by
x.
x into ln of sin x,
ln of sin x
right? Plus ln x
yes
into derivative of ln of sin x. So basically now you are trying to differentiate ln of sin x.
1 by
So
sin x
which
into
function is
cos x.
inside which function?
Sin x is
Great,
inside
great.
ln of x.
1 by sin x into cos x.
Correct, correct, Vignesh. So when I do this, I get 1 by x. So I'll get 1 by sin x into cos x. Correct. What is 1 by sin x into cos x? It is cos x by
Cot
sin
x.
x, right?
Cot x.
Cos x by sin x is cot x. Great. It is
Cot
cot
Yes.
x.
yes sir.
It is cot x. Right? Agree, everyone? So I can just directly take my dy by dx. So it is sin x raised to ln x into 1 by x ln of sin x plus ln x into cot x. Great work. This is it, everyone.
Sir,
Yes.
y
Okay.
where is y
Yes,
sir?
ask.
1 by y
My see, I took this y on this side, okay, and my y value was already given to me, sin x raised to ln x. So I just
yes
kept
sir.
it back. I just kept it back as original values of x, original function of x. Fine. Okay. So just one last question, and this one is actually not like after seeing this question, you won't feel that it is a question related to logarithmic differentiation. So you have got uh, square root of x minus 1, x minus 2 by x minus 3, x minus 4, and x minus 5, something like this. Right? And now it is asking you dy by dx. So if you see clearly, you can be applying chain rule over here. Do you all agree? You can apply chain rule over here. But the chain rule will go really complex because you have got 5 functions that are multiplied and divided with each other. And along with that, you have got a very long square root. So first you will need to handle the square root. Then you will need to handle 2 functions that are divided with each other. So it will go really long. So this function can be done easily using logarithmic differentiation. Let us see how we can do this. So you have got, okay. So let us take the natural log on both sides. Can you help me and tell me what will be the value of natural log on the right hand side? Anyone?
1 by 2
What will
into
happen if I take natural 1 by 2 into, tell me,
log
1 by 2 into
Log
log
of x minus
ln of
1 into
minus
x
1 into x minus
into x
2.
minus 2 minus ln of x minus 3 into x minus 4 plus x minus.
okay, great, correct. So basically the rule that you are trying to say is that if 2 functions or if 2 logarithm have been added, right? So it is equal to ln of a into b, right? This is what you are talking about,
Yes, sir.
right? Ln of a into b can be written as ln a plus ln b. Similarly, ln of a divided by b can be written as ln of a
Ln of
minus
a
ln of b.
minus ln of b.
Right. Great. So over here, what is happening is half of. So this, what is this half doing? This half is basically representing my square root, right?
Yes, sir.
Because you have got this whole thing as a power, right? So this half will basically denote your square root, half into. So x minus 1 and x minus 2 are being multiplied to each other. So I can write it as ln of x minus 1 plus ln of x minus 2, right? And x minus 3, x minus 4, and x minus 5 are in division. So I can subtract all of these.
minus ln of x minus 3 plus x minus 4.
Yeah. Correct? Everyone? This is correct?
Yes, sir.
I have added x minus 1 and x minus 2 and subtracted x minus 3, x minus 4, and x minus 5 because they were in division. Now, if I differentiate both sides with respect to x, right? I differentiate both sides with respect to x. What will be the value of, let us take the left hand side. I differentiate my left hand side with respect to x. What will it be? Anyone? What will it be?
1 by y into dy by dx.
Dy by dx, yes. 1 by y into dy by dx. Right? We have been doing this for so long. So I'll keep my half as it is. Now I will be differentiating this long thing. So I have got ln of x minus 1. What is the derivative of ln of x minus 1? Anyone?
1
ln
by
of x minus
1
1.
by x minus 1
How much? Great.
into 1.
What about? Yes, 1. See, we had discussed this earlier also, if you remember. I had
Yes, sir.
told you that if you have any linear function of x, so what we can do is we can just directly take f dash of ax plus b and then multiply it by a. So over here, your a is 1, right? Your a is equal to 1. So that is what we are doing. So I can just directly write it as 1 by x minus 1, right? Plus, what about
1
x minus 2?
to
1
1 by,
1 by x minus 2.
great. Minus, what about this thing?
1
ln
by
of
x
x minus 3.
1 by x minus 3
1 by x minus 3
What about
minus 1
this?
by x minus 4.
minus 4 minus 1 by x minus 4.
Great. So you have got this thing. So basically now you have calculated your value of dy by dx as y by 2 into this whole thing, right? This whole thing as it is. Fine, everyone?
yes sir.
Yes, sir.
Right? Okay. Great. So let us just do one small conceptual question. So it is asking you that f of x is given to you as some function. Let us see how we can do it. It looks really complex, but it is not actually. Fine. So you have been given a function f of x, whose value is limit h tending to 0, sin x plus h raised to cos x plus h minus sin x raised to cos x whole divided by h. And it is asking you what is the value of f of pi by 2. So can anyone think of it? What does this thing mean basically? Or let me just give you one simple representation. So for example, you have been given a function g of x, okay? You have been given a function g of x. What does the first principle tell you? Everyone remembers first principle of derivative? What is the first principle of derivative? First principle of derivative tells you that g dash x is equal to limit h tends to 0, g of x plus h minus g of x whole divided by h. Everyone remember this?
Yes, sir.
Everyone? You remember it? Okay,
Yes,
great.
sir.
Right? When we took 2 points that were really close on the curve, we plotted the points, we took the slope of the line, right? And we proved it, that limit h tends to 0 was this. So if you look closely into this function over here, in the function in the top, so if you take your g of x to be sin x raised to cos x, right? You take your g of x to be sin x raised to cos x. Can you tell me what is f of x basically? Like, what are they asking you? What is f of x denoting? Just think your g of x as sin x raised to cos x. So what is your f of x basically?
G dash x minus g of x by h.
Are you sure it is? So you told g dash x minus g of x by h. This is this what you're telling?
Yes, sir.
Think again. You are close, but not correct. Can you tell me what will be if your g of x is sin x raised to cos x? What is your g of x plus h?
Sin of x plus h raised to cos of x plus h.
Great. So what is your f of x basically?
G of x plus
Your
h
f of
minus
x is
g of x by h.
so what is this thing? This thing, right?
Yes, sir.
Yes,
So what
sir.
is f of x basically? Right? Can I say it is equal to g dash x?
Yes, sir.
Yes, sir.
Everyone, right? Everyone? Anyone has any doubt why f of x is equal to g dash x? Right? Because it is basically g of x plus h. See, I am telling you that g of x is sin x raised to cos x. Right? It is sin x raised to cos x. Everyone, any doubts? Anyone?
No, sir.
No.
Sure. Understood, everyone? See, your g of x is sin x raised to cos x. Okay. So your g of x plus h will be sin of x raised to h raised to cos of x plus h. So this thing is basically your first term over here is basically g of x plus h. So it is g of x plus h minus g of x whole divided by h. And what is this value equal to? It is g dash x. So basically your f of x is the derivative of this function sin x raised to cos x. So your f of x basically denotes derivative of sin x raised to cos x. And it is asking you what is the value of f of pi by 2. Okay. So first of all, you will calculate your derivative and then you will substitute your value of x is equal to pi by 2. So how will you take the derivative of sin x raised to cos x? Tell me, how should we do it? Sin x raised to cos x.
By applying logarithm.
Okay, great. So I take ln on both sides. So what will be the right hand side that I get?
Sir,
Cos
Tell,
x
the
root
right
of
hand side
sin
that I
x.
get.
Sin x.
sir,
Yes, Vignesh.
is it g dash of x is sine raised to cos x?
Sin of x raised to cos of x. Sorry, can you repeat your question?
So is it g dash x is sine x raised to cos x?
No, g of x is sin x raised to cos x. G dash x means the derivative, right?
Okay, sir.
G dash x basically means derivative of that thing, right? So I want you to differentiate this stuff with respect to x. So when I do that, I'll get, what will I get? 1 by
1
y
by
into dy by dx,
Divided by dx.
right? 1 by y
yes.
into dy by
Yes.
dx, right? Is equal to. So I differentiate my first function first. So I get minus sin
Minus
x,
sin x.
right? Right? Minus sin x into ln of sin x plus cos x
Cos x.
into. Can you tell me what will it become?
1 by sin
1
x
by
into
ln of
cos
sin
x.
x, what?
1 by
Great.
1 by
sin x.
sin x into cos x.
Cos
Great
x,
work.
sir.
Great, great. So now it has been told to you, that your value of x is pi by 2. That your value of x is pi by 2.
Yes.
So over here, I need to find dy by dx. So I would need to find the value of y also. So can you tell me x is equal to pi by 2? So what will be your value of y? Value of y.
X minus
What is sine of pi by 2? What? X minus?
pi by 2.
X minus pi by 2. How?
No, sir.
See, your y has been already given to you, right? Sin x raised to cos x. So
Yes.
over here, you can just substitute your value. So just substitute this thing and tell me. What is sine of pi by 2?
0.
1,
1,
sir.
sir.
Sine
1.
of pi by 2 is? Sine of
1.
pi by 2 is 1. Great. What is cos of pi by 2?
0, sir.
0,
What
sir.
is?
Sir.
Great. 0. What is 1 raised to 0?
1, sir.
1,
1,
sir.
sir.
Yeah, 1. See, just keep this mind map always with you, okay? I used to remember it during my time. So for sine, it works like this. And for cos, it works like this. Fine. So whenever you have a confusion, just remember this thing. It will really help you. So I hope all of you know what this thing means. So this means positive x-axis. This means positive y. This means negative x, and this means negative y. The same thing over here. So it will easily like make you remember the values of cos and sine in any cases. So 0, 0 on x in case of sine. So this is for sine and this is for cos. Fine. Great. So now all I'm left with is to calculate what is the value of dy by dx. So 1 by 1 into dy by dx. So now I just need to input my values. So sine of pi by 2, what is it? Sine of pi by 2 is 1
Minus 1.
into ln of 1 minus 1 into ln of 1 plus. What is cos of pi by 2?
0.
0,
0,
sir.
sir. Whole
0.
value
So this
0.
whole thing becomes 0, right? Great. What is ln of 1?
0.
0.
Natural
0,
log of
sir.
1. Yeah, 0.
0.
Great. So
0.
my value of dy by dx, what is it? My
0.
value of
0.
dy by dx?
0.
Great one. 0. Right, everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, great. Okay, so just one small like we can just take it as a proof also. So you have been given a function y whose value is a raised to x. A is any constant greater than 0. Okay. So you can take natural log of y. So this becomes x into natural log of a. Right, everyone? Correct?
Yes, sir.
Yes, sir.
So if a is constant, natural log of a is also constant. So if I differentiate it, it will become 1 by y into dy by dx. What about my right hand side? Can anyone tell me what will be the derivative of my right hand side? My derivative of right hand side, what will it be?
X by a plus
Anyone?
ln of
Why would you? I'm telling you that ln of a is a constant.
Yes, sir.
So what will be the derivative of x into ln of a? Like this thing is a constant. Just treat it like a constant. A is a constant, so ln of a is also constant. So x into some
Yes, sir.
constant. So you get cx. What is the derivative of cx? C is any constant.
yeah,
Sir, is it C?
Yes, it is ln of a, right? See,
Sir.
a is any constant. A is any real number. Okay, any constant real number. So what will be the value of ln a? Ln, natural log of a constant, that is also constant, right? So great. So it will only be, right, x, like how do you take d by dx of 5x? So you just write it as 5, right? D by dx of 7.5x. So you just write 7.5, constant. So over here,
Yes.
your natural log of a, that is also constant. If I give you d by dx of natural log of 5 into x, what will you do? What will be the
ln
value?
of 5.
Yeah, because it is a constant. So you'll treat it,
Yes.
this whole thing like constant, right? So what will be your value of dy by dx? So value of dy by dx will be y into ln a, right?
Yes, sir.
So your y is basically a raised to x. So a
A
raised to
A
x
raised
into
to
ln a.
ln a.
So now you have got the derivative of a raised to x. A is any constant. Fine. Everyone got it?
Yes, sir.
Yes, sir.
Okay, great. So I just give you one small question for homework in this also. So you have got your y as x raised to x raised to x. And I ask you to find dy by dx. Fine. X raised to x raised to x. Let us see how we can do it. Fine. So that's it for today. Anyone, any doubts in today's class?
No,
Till
sir.
now, whatever we have done, any doubts? Okay.
No, sir.
So just keep in mind to revise such special questions related to inverses. Such inverse questions have been part of previous year questions also in JEE Advanced also. So just keep in mind to understand these properly. And I know many of you have forgot this property also related to inverse. F inverse of x is x and f of f inverse x is also x. Just keep that in mind. Okay, fine. Sir, can Arun sir?
Yes, sir. Yes, sir.
Okay, thank you, thank you.
Thank you, sir. Students, join the next session.